Okay, so let's go over the answers to this practice quiz for the test. So question number 1, an oxygen atom has atomic mass of 17. Its atomic number is 8. How many neutrons does the oxygen have? Well, you should know by now that this is mass number minus atomic number, which just means that we have 17 minus 8. So the answer should have been 9. So this one does have some different numbers in it. So if you didn't have 17 and 8 in there, you might have had a different number, but this is how you do it. You take the bigger number, the mass number, and you subtract out the 8, okay? So you should have got something like that for the first one, question number 1. Okay, question number 2, we're gonna pull this periodic table out, okay? So it's asking for the Lewis structure for phosphorus. So the first things first, we need to figure out how many valence electrons we have, right? Because this one has 5, this has 8, this has 5, and this has 1. So if we look at our periodic table, we look around and we see that phosphorus is right here. That's in group 5A, so I know that there should be 5 dots around the phosphorus. So I have 2 options now. I've canceled out this as an option, I've canceled out this as an option. So the next step then is, well, how do we put the electrons? Well, remember that if electrons do have room, they want to spread out first. So these guys are paired up and these guys are paired up, but there's room over here. This isn't correct. What we want is spread the electrons out, so you have a spot here, a spot here, a spot here, and a spot here. Put 1 in each one, and then when you have that 5th one, then double it up. Okay, so this should have been our correct answer. All right, so that's number 2. Number 3, so again, we have our trusty periodic table here. So we're looking at magnesium, it's neutral. So those are the key words there. So we want valence electrons. Remember, these are the outer energy electrons. Very easy way to tell. By the way, let's find magnesium. I see it right here. So this is the element we're looking at. Valence electrons, super easy to tell. You just look at what group it's in, okay? And by the way, this is also known as 2A. So the number of valence electrons for magnesium would just be 2. It has 12 total, we can see as in the atomic number, but only 2 of them are on the outer high energy level. How many protons does it have? That's easy, it's the top number, 12, right? It's that number right there. Group number, 2A. An atomic mass number, right? So that's the bottom number, but atomic mass number, yeah, that's the whole one. So 24.31. Oh, my bad. Mass number, 24. We're going to round it. Okay, so that's number 3. Number 4, look, again, I have my periodic table. That should let you know. You better have that periodic table ready to go when you take your test. I mean, just real quick, all the questions are there. So, all right, number 4, the correct orbital diagram for chlorine. So let's go check out chlorine. Okay, right here. Oops, not let me draw on it. Right here we have chlorine. It has 17 electrons. We know from the atomic number. If it doesn't say it's an ion, we know that the same amount of electrons as protons exist. So that 17, the atomic number tells us protons, but in a neutral atom it also tells us electrons. So we count these up and we see that both of them have 17. So the issue is not how many electrons we have. The issue is this. When we get to this 3p energy level, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, never mind. I was thinking of a different one. This would be the correct answer. And the reason why? It has 17 electrons. I just counted up the arrows. Easy. This one has 18, so that would not be chlorine. That's kind of more like argon, right? Okay, so that's number 4. Okay, number 5. What is the correct electron configuration for germanium? Okay, so germanium is right here. So it has 32 electrons in it, okay? All right, and then going in order on your electron orbital diagram, you should remember that, look, they all start with 1s2, that's correct. They all go to 2s2. They all go to 2p6, they all go to 3s2, they all go to 3p6, they all go to 4s2, and then right here is where we need to start paying attention. After 4s2, right, it seems like we could probably go to 4d. The problem with that is that after 4s, we don't have 4d, we have 3d, right? So if you look at that orbital diagram we gave you, the next one after 4s is 3d. So we can eliminate this one because it's not 4d, it's 3d, right? That right there. And then it's not 4p next, it's 3d. So we can eliminate this one as well, okay? So that's how you should be doing it. And then now that we have that, we have 3d10 and 3d10, and then 4p2 and 4p6. Well, if we go back here, if we counted it up, germanium is right here. So it's in the second spot on the p orbital there. So it only has 4p2 electrons, right? It's only got those 2 electrons. So this is the correct answer, okay? So again, just fill out your orbital diagram and then just start writing in the correct ones, and you'll be able to figure out all of these, okay? What is the mass number of an element that has 18 protons, 20 electrons, and 12 neutrons? So hopefully you remember that mass is a combination of our protons plus our neutrons. So it should be 18 plus 20, sorry, 18 plus 12, my bad, equals 30. That would be our answer in this case. What do we do with the 20 electrons? Nothing. They don't really have much mass, not enough to make a difference. It's just there to trick you. So make sure you pay attention. It's just protons and neutrons for mass. Okay, so now we're trying to figure out what element this is. So I told you a nice little trick here. This top number is our electrons. So we have 1, 2, 3, 4, right? Plus 6 is 10 electrons. Plus 2 more is 12. Plus 6 more is 18. Plus 2 more is 20. Plus 4 more is 24 electrons. Okay, if we look over here, I see 24 electrons right here. Chromium. Easy. Just add up those top numbers. And then, yeah, notice where chromium is as well, right? This is 4, so we know this is 4s1, 4s2, and then it's 3d1, 3d2, 3d3, and then 3d4, okay? So that's the other way, 4s2, 3d4. All right, shorthand. So for number 8, shorthand, we